All right, today we have 1.2, algebraic expressions and models. A lot of it's going to be vocabulary. The first vocabulary we have is called a numerical expression. Numerical expression has numbers, it has symbols, and it has operations. An expression does not have an equal sign. So 2 plus x is an expression. 3 minus 4 is an expression. Numerical expressions only have numbers, symbols, and operations. Next we have base and exponent. This should be familiar to you. The base is the large number. The exponent's the number to the raised to the top right. And if you were to expand a base and an exponent, you would write out the factors, the number of times the exponent tells you to. So 3 to the 4th means 3 is the base, and that you have 4 factors of 3. When it comes to numerical expressions, the number one way that we implement this is through our order of operations. Now, most of you are familiar with PEMDAS, or please excuse my dear Aunt Sally, or what other acronym that comes about. But we really try to move away from that because the P, which stands for parentheses, is no longer really valid here. Because what we have here is no longer just parentheses. We have what's called our grouping symbols. They can be parentheses, they can be brackets, or that really large fraction sign. That fraction symbol is also known as a division symbol, and it separates a numerator from a denominator, and it does tell you if there's more than one thing going on in the numerator, you have to simplify that first, or the denominator doing that first as well. But grouping symbols is the first order of operations. Do whatever inside the grouping symbols, or above or below the grouping symbol if it is the division bar. Now, normally the next one, PE, E is the exponents. Well, same thing, powers. Powers and exponents mean the same thing. We sometimes will have many exponents and many powers within an order of operation. So you need to make sure you take care of all the exponents first. And this is why we don't use the PEMDAS, or we really move away from it. The M and the D, it is multiply and divide from left to right. You do not just do the M first because it came first in the PEMDAS. You do whichever one comes first in the order of operations in the expression. If division comes first, that's the one you do first. You do multiply and divide in order from left to right. The one you see first is the one you do first. And the same thing happens with add and subtract. You do whichever one you see first. It is not always add. So you need to make sure that you're following the proper order of operations and not just some letter acronym. And remember, we always move from left to right. Next vocabulary word is a variable. A variable is a letter that's used to represent numbers. A value is any number that replaces the variable. So the value of the variable. If we say x is 2, then 2 is the value of x. So value is the actual number that replaces the variable. Once we start using letters, We are now moving into an algebraic expression. An algebraic expression differs from a numeric expression, which was the very first vocabulary word, because it now has variables in it. Once you start throwing in x, y's, a's, whatever, you are now using algebra. And that's where our algebraic expressions come in. Evaluating is another word for substituting. When we substitute a number in for a variable, it's called evaluating. Make sure you understand the directions in that, because the directions don't read substitute 2 into x. It'll say evaluate x for the value of 2. Evaluate, substituting, they're the same process that you do, but you're going to see the words evaluating more than substituting. The value of an expression is the result you get after you substitute, after you evaluate. Once you change x to 2 and y to -1 and z to 0, whatever substitution they want you to make, whatever evaluation they want you to make, when you combine them using your order of operations, you get the value of an expression. Mathematical model is a real-life situation. These are your word problems. These are things that you're going to be doing a lot of. We have to start applying it to real-life things. So that's what a mathematical model is, a real-life situation. Terms. Terms are the parts that are added or subtracted. They can be numbers, they can be letters, they could be letters with exponents, but they are the parts that are separated by a plus and a minus sign. So here we have 2x plus 3 minus 4y squared, and we would say there are 3 terms. 2x is a term, the positive 3 is a term, and the negative 4y squared is a term. And you really want to be careful that you are including the signs. Even though the signs are separating the terms, the signs are part of the terms. And we don't want to lose the fact that 4y squared is actually a minus 4y squared or a negative 4y squared. That sign does go with the term. The sign just separates to tell me it's a new term, but it does go with the term. Then we have coefficient, which you should be quite familiar with. Coefficient is a number being multiplied to the variable. And using this exact same example from above, we have 2 coefficients. The 2 that goes with the x, the 2 is called the coefficient of x. And then the negative 4, which is the coefficient of y squared. Again, pay attention to the sign. It is a negative 4 that's the coefficient of y squared, not just the 4. Always read a sign that goes with the number. Then we have like terms. Like terms require it to have the same variable part, including the exponent, because the exponent's connected to the variable in most cases. So therefore, the variable part has an exponent on it. The variable and exponent must be considered one connection. Here we have the example 2x plus 3x squared minus 4x. The like terms are the 2x and the negative 4x. The 3x squared is not the same. It has a square on it, therefore it is not the same exponent that goes along with the variable, even though the variable is the same. X and x is not enough. It must, or x and x squared is not enough. It must be the exact same letter, exact same variable, and exponent in order to be able to combine them together. So only the 2x and the 4x get to be considered like terms. The rest of them, or just the 3x squared, is not. Okay? Equivalent. Equivalent is the same value for all values of the variable. Equivalent is equal. And you can see the word equal almost in the word equivalent. But we don't use the word equal. It's just kind of a little mathematical thing. When we say things are equivalent, yes, we're saying they're equal, but we're just using a different terminology. The same value for all values of the variable. So 7x plus 4x is the equivalent to 11x. No matter what value I put into my x's, I'm going to get the exact same value on the left side as I do on the right side. So they are equivalent or equal. We also call this an identity. When the left-hand side equals the right-hand side, when they have the same value for every single letter value, it's an identity. So we use the equivalent more when it is a letter or a variable in my equation. Because my variable can change, x could be 1, 2, negative 5, 7, 1/2. I can change my x to be anything. Therefore, the left-hand side will always be the same value as the right-hand side because they're equivalent even when I'm changing my x. All right, so those are the vocabulary notes and stuff that we need for 1.2. You're going to be asked to do some order of operations, do some substitutions, evaluatings. Go back and give me some identities from 1.1, and we'll work on that in class.